Hi everyone, welcome to Tech Tutorials 2K21. So today we are at day 11 live session in Master Course Java 30 days course, and our topics to discuss today is polymorphism and abstract keyword in Java programming language. So we'll start with the polymorphism. We'll see what is the definition of polymorphism and how many ways we can create a polymorphism in Java programming language. What are the different types of polymorphisms we have and how you're going to implement. We'll try to understand with a simple examples. Then we move on to the topic of using of abstract keyword in Java programming language. So this is about today's topic. So I'll start with polymorphism. So simply we can say polymorphism is nothing but it's a mechanism in your object-oriented programming where an object can have a multiple behaviors. So we can say an object is in multiple behaviors. Then simply we can say it's a polymorphism in object-oriented programming. So you can take any object-oriented programming like C++, Java, Visual Studio, whatever the object-oriented programming languages we have. So this mechanism is said to be a polymorphism. Um, Suppose, for example, we come up with a real-time example. Suppose for myself, I'm an assistant professor in CSE department. So I can go for a multiple classes to teach a multiple subjects. So I'm a single person. So I am an object in a real world. So I can go for a multiple classes like third CSE, second CSE and final year CSE. And for every class, I'm going to teach a multiple subjects. Suppose, see, for example, for second years, I'm going to teach Java. For third years, I'm going to teach compiler design. For 5 years, I'm going to teach web technologies. The same person depends on the situation. They're going to behave in different ways. Right? Suppose if I go for second years, so there I can deliver Java programming. If I go for 5 year, I'm going to teach there web technologies. So the same person can behave in multiple ways. So you can take any other real-time examples like suppose you are a person, suppose you are a man or a woman or girl or a boy. So now you have a different characteristics different behaviors depends on your character. Suppose see simply you are a person, so you'll be acted as a brother and you will be acted as a son and you will act as a husband. Like you have a multiple roles and depends on role your behavior is changed. So these are some real-time examples for polymorphism. So in Java there are two types of polymorphisms are existed. So one is compile time polymorphism and the second one is runtime polymorphism. So these are two types of polymorphisms. So the compile time polymorphism is also known as a static polymorphism. So we'll move on to the compile type polymorphism. So simply we can achieve this compile time polymorphism by using the method overloading concept. When what do you mean by a method overloading means when you take a class which having multiple methods with the same name. Like we have more than one method and that method is having same name. So such type of methods in your Java programming is said to be method overloading. Like they can have a same name but they are differ in their parameters or the type of parameters you are passing or the order of parameters you are passing, and they can differ in these three matrix. So simply what we can say, method overloading is nothing but the class is having multiple methods with the same name. So methods are having same name, but they are differ obviously. So otherwise the compiler cannot recognize which method is going to your initiated by you. So how it is going to be differentiate the methods from the given the methods in the same programming multiple times. So it can differentiate from method to method by using, by checking the number of arguments you are passed and the type of arguments you are passed and the order of arguments you are passed. So it depends on these ways we can overload the methods in your Java programming. And this method overloading concept in your Java programming is used to achieve compile time polymorphism. So what do you mean by compile time polymorphism is nothing but so where the objects are bounded with their functionalities at the compile time. Like we can know that which method you are going to use before we are going to execute. So at the time of compilation itself you know that which method you are going to initiate, right? So because of that it is said to be compile time polymorphism. And a second, so before we are going to take a explanation about a runtime polymorphism, so we'll go with an example for a compile time polymorphism. So I'll give you a simple example. So now you can, so I already, so here I'm trying to open my program because it is already existed. So now you can see this is an example for method overloading, and you can find out here area is my class name. So you can find out area is my class name and here my method name is find. So we cannot differentiate the methods by its return type. So remember these are the return types and these are the data types. The type of arguments and the number of arguments and the order of arguments is going to be deferred your methods in your method overloading by your Java compiler. So we cannot consider like void, int or something because these are not data types and these are return types. So why I am using void here? Because I don't want to expect anything from my main function. I cannot expect anything from my function. So simply I can use void. So what simply I am doing here? So I can take two values, that is length and breadth, and I'm going to find the area. So this is area of rectangle. So we know that this is an area of a rectangle. So simply I can calculate the area of a rectangle by L into B. And after that I am using the same method, and here you can observe that here I have two arguments and here I have three arguments. And we can find out here I have two integer arguments and here I have three integer arguments. So how you can achieve method overloading in Java? Either you can change the number of arguments or else you can change the type of arguments or you can change the order of arguments. So I will show you the three cases so that you can understand. So now here you can observe that here the method is overloaded by the number of arguments we are passing. So here I have a method find, and by this find method I am taking three arguments of type integers, length, breadth and height. So by this I am going to find out the area of cube. So this is the area of a cube, that is length into breadth into height. So now this my find function will do. So I can take so another method. So you can take any number of methods. So because that makes your method overloading, right? So I can take another method, and here I can take simply it is a. So I'm given side here. So here I'm going to print the area of square SQUARE, area of a square. So that is, so I know area of a square equals to side into side. Okay, so this is the formula for area of a square. So simply I can take as a square. So this is my main method. Here I am creating an object to my class area. So by that object, when I am calling this method, I am going to pass the values. So what it expected, so now I need to call one more method. So simply I can take one more method. And then this method is going to pass a value for my find method, which is having only one argument of type integer. Suppose if I am given like 6. So no need to call your methods in a same order which you are implemented in your program. So you can change the order also, right? See here, I change the order because you can find out that at the time of implementation. So here I have a method with 2 arguments, and here I have a method with 3 arguments, and here I have a method with 1 argument. But at the time of when calling this methods, so simply I'm call my method with 2 arguments first, and then with 1 argument, and then with 3 arguments. So whenever I'm calling, so what my compiler will do is, so it can link your calling method with your function definition. So here I'm calling a method with 2 arguments, like it is going to bind with this method. And here I'm calling with one argument, which my method find. Now it is going to match with this. And for this, it is going to match with this. So now I just save this program because I'll make the changes. And then here I'm going to execute this program. So in command mode, simply I can change my class path because I know my programs are saved at desktop at location in HTML file, HTML folder. So here I need to give Java C area dot Java. Oh my god, I missed a semicolon there. So here I need to provide a semicolon because I missed here. That is a compile time error because your Java, it must follow the syntax. So if you make any errors in your syntax, then it will show you an errors. So I again recompile my program. So now you can find out here I need to give my interpreter to execute my program area. So now you can see. So it will give me like the order which I am calling. So first I'm passing with 2, I'm calling a function with 2 arguments, and this is going to find the area of rectangle. So it will show me output as the area of a rectangle. And even though I'm taking this order because of this method callings, and these methods can be chosen by your compiler, and those methods is going to execute. So after that it is called your find method, which is used to find the square area, so area of a square, and after that area of a cube. So this is how you are doing method overloading with changing the number of arguments. So I just copy and paste here because I need to pass this, right? So now, and we'll see now in a same class I'm going to make some changes. So what I tell the second one, like you can change the type of argument you are passing. So here I have 2 arguments, so I don't bother about how many number of arguments I'm passing here because I'm not considering that here. And here I'm considering the type of argument. So here I have two integer type of arguments. So now I make here double, right? So double, and here I need to pass, this is a float, and these two are integers. Now you can see these two are integers, and here I have one integer, one float, and one integer again, and here I have double data type. So now you can see in this program I'm implementing method overloading concept by changing the type of argument, right? So depends on this, I need to make the changes in my method calling also. So in first method I need to pass two integers. Okay, it is okay, but I change the values. So here I'm passing 12 and some 15, and here I need to pass one double. So here I need to pass double values, that is 5.63, some f or something, here I'm passing here. And then here I need to pass two integers and one floating point. So here I'll make this as a floating point number. So now you can see two integers here and one floating point here. So I can rearrange the callings. So I just execute this program. So I just save this modifications and then I recompile this program. Okay. Possible loosey conversion. Okay. So now you can give here, you can provide f. I'll save. So now you can find out here my program is successfully compiled, and here I need to provide my interpreter to run this program. So now you can find out here, see, area of a cube. So why it gave me area of a cube first? Because here I'm calling my method with two integers with one floating point. So what it is going to do? It is going to find the area of a cube. So because of that reason, so it is going to call this method first. So area of a cube. And after that, I'm having two integers, and that method is going to calculate the area of a rectangle. So it is going to calculate the area of rectangle. And area of a square, so which I am taken a double, and we have for double it's having a precision value as 18 or 12 or 18 it's having. I think yes, it is more than 12. This is how you are going to achieve method overloading by changing the type of arguments passed in your method. And the third way is you can change the order, like you can change the order. So suppose here we have we can observe that here. Okay, so here I have one float and one float and one integer, and here I have one float and one integer. So here I'm trying to find the area of triangle. Okay, here I'm going to find the area of a triangle. So now that is half BH, right? So half I can take 0.5 because I converted into floating point, and then I'll multiply it with my breadth and height. And now you can see, and this is also having two arguments, and this is also having two arguments, but the order is changed. So in this method I have an integer and float, and in this method I have float and integer. So even these two methods is having two arguments of same type, but the order is changed here. So depends on that, the compiler can recognize which method is you are going to initiate or instantiated. So now depends on this, you have to change the values here, right? So first you have to provide one integer and one float. So for this, and here I need to provide one float and one integer. So right, I think it is fine. So now here I need to provide one double value. So everything fine. So now how my method is overloaded here. So here I changed the order of parameters in my method. Okay, so this is the third way how you are going to implement the method overloading. So I simply execute and I simply run this program again. So I'm compiling my program and here I'm going to execute it. So now you can find the area of a rectangle and then area of a triangle and area of a square. So I hope you all can understand what is method overloading. So method overloading is a concept which is used to implement your compile time polymorphism. So poly is nothing but many. Morphism is nothing but changes. So many changes, many behaviors. So whenever in your programming, your object is going to be act in a different way, it depends on the situation. So then you are going to use the concept of polymorphism in object-oriented programming. And depends on when you are going to make the object behavior changes. Means at the compile time you want to make the changes or at runtime you want to do that. So depends on that you can implement either compile time polymorphism or runtime polymorphism. So compile time polymorphism can achieved by method overloading. So we don't have any operator overloading concept in Java. So it is having in your C++. And we already discussed at the time of constructors, we discussed about the constructor overloading. So because we know that constructor is also a special type of method in Java, but the purpose is which is going to initialize. So there also we can do the things. So we can say like constructor overloading or method overloading. So is a way how you are going to implement your compile time polymorphisms. Now coming to our next thing is runtime polymorphism. So the runtime polymorphism is also known as path dispatch or else so runtime polymorphism is also known as a dynamic method dispatch. So it is a process in which a function called to the overridden method is resolved at runtime. So at the time of running your program only you can identify that which method you are going to taken. So that is going to be binded at runtime. So whenever we have that situation, then you are going to use the runtime polymorphism concept and we can achieve runtime polymorphism by using method overriding concept. So there will be a difference between method overloading and overriding. So first of all, we'll see what is a method overriding. Then we'll make the differences between method overloading and overriding concepts. So in method overriding, so it is a feature that allows us to redefine a method in the subclass or derived class which is already defined in its parent class or a superclass. So we know in inheritance concept we have a relationship between the parent and the child. So what your method overriding will tell you is, so it is a mechanism like you can redefine the method which is given in your parent class by your child class. So that can achieved by using this method overriding concept in Java programming. So in any object oriented programming languages we can take. So we can implement this method overriding only when two classes have a relationship like is A. So like we have only one from one class to another class we have derived. So there is no situation like more than one class is going to be derived from a single class. So we can implement this by single inheritance. Simply we can say because there is a relationship of is A. Whereas as A relationship is between we have like hierarchical inheritance. Like we have one parent class and we have a multiple child classes. So there we cannot implement this of course. So between them and then using this method overriding a derived class or your child class can provide a specific implementation of a function or a method that is already existed in your parent class. So in method overloading, what simply we are doing, we can take the same method name, but we don't bother about that what will be the return type and what are the arguments we are passing there. Whereas in method overriding, so the method it must be, means the method prototype it must be similar in both parent class as well as your child class. So then only the compiler can recognize the methods, because we have to override, means the same method you can take and you can override with the current values with the previous values. So that is a concept of overriding. So I'll show you an example for override. So I hope it is okay. So we have a method overriding demo.java program is there. So I just open it and I'll explain you. So here we have a class shape, and in this shape we have a method draw. So draw is a method which doesn't having any argument. So what simply I said, like in method overriding, so we have the method name and the return type and everything. Like suppose we have any arguments here, and in your child class is also we have a method with the same prototype. Then only we can override. Otherwise we cannot override in your child classes. So method overriding will give you an opportunity that the child class will give a multiple definitions for your parent class method. So like your parent class method, it will do one thing. The same method in your child class, it is doing another thing, right? So for method overriding, we must implement the inheritance concept. We have to remember, for method overloading, we don't need. For method overriding, we must use the inheritance concept to implement the overriding concept. And remember here always the method prototype, it must be similar. See here we have one method and the same method prototype we are using in your child class. So then only these two are same. So now what simply I am doing in my parent class, I am using my system.out.println. I am just simply displaying some message like inside the method of parent class, and it is going to draw a shapes. It is going to drawing a shapes. So here I am using circle, which is going to extend it from my class shape, and I have the same method which is defined in my parent class. And here in my child class, I am going to override my method with some other statements like inside the overriding method of the child class and drawing. Here I am drawing circle. And this is my main class, and my main class name is method overriding demo. So this is my main class, and here I am creating an object to my parent class. I am going to call the method of my parent class. So this is a way how you are going to create an object for a parent class, and this is the way how you are going to create an object for your child class. So as of now, in inheritance concept, we simply create an object for the child class, and by using that object only, we are initiating all the, or else we are instantiate all the methods of your parent as well your child classes. So whereas in method overriding, so how you are going to create an object for your child is, we are taking the reference of your parent class. See here, the object creation is changed. So we are going to create an object with a parent reference to a child class. So this is my child class. So now I am creating an object for my child class with the reference of my parent class. So now I am calling the draw method. It is going to execute the same method in my child class. Because see, in method overloading, even though we have same method name, there will be difference. So now that your compiler can recognize among of all the methods which method you are initiated by your object. So whereas in method overriding, there is no concept of differentiation in the methods, because the same method what we have in your parent class, in your child class is having the same. So we cannot differentiate whether you are calling the method of your child or the method of your parent. So simply you want to call the method which is defined in your parent class. You can create an object for your parent class and simply you can call by that object your overriding method. So now for child class, do you want to call the overriding method? Simply we can create an object for your child class with the reference of parent class. So that is the concept of here. See, here we are using the reference of parent class and we are going to create an object for your child class circle. So by using this object 1, if I am calling a draw method, now it is going to call this method. So in that way your Java compiler can differentiate the same method called by whether it's parent class or child class. So this is the concept of method overriding. So by this method overriding, so we can implement the runtime polymorphism in object-oriented programming. So I'll execute this program. So here I'll give you Java C, and my class name is method overriding demo.java. And now I need to execute this. So now it will show me like inside the method of parent class, I'm going to drawing the shapes, and inside the overridden method of the child class, I'm drawing circle. So this is of method overriding. So now in this way we are going to achieve a runtime polymorphism in object-oriented programming. So even in C++ or Visual Studio, whatever the object-oriented programming we have, so those we can implement by using this method overriding only, right? So then here I hope you all can understand the difference between method overloading and overriding. So method overloading is used to implement your compile time polymorphism, whereas the method overriding is used to implement your runtime polymorphism. And method overriding, that is your compile time polymorphism, is also known as a static polymorphism, whereas the runtime polymorphism is known as dynamic method dispatch. So in method overloading, if you want to overload your method, simply you can give the same method name multiple times in your program, and you can differ with 3 parameters. Like you can change the number of arguments given to your method, or you can change the type of arguments you are passing to method, or the order of arguments you are passing to method. So in that way you are going to achieve the method overloading concept in OOPS. Whereas in method overriding, so we can use the concept of inheritance, and there the method overriding will provide you a feature like we can override the method in your parent class with your child class, right? And that can achieve simply you can give the same prototype or the same method name in both the parent class as well as your child class. So we move on to the next topic. So that is an abstraction. So we know simply abstraction is nothing but it's a process of hiding the details, and we are providing only the functionality part. So we cannot provide any details about the things. We can provide only the functionality. See, go with for example a real-time examples. So now you are going to fill one application to apply some job. So you can go with some portal. You simply open your portal, and now by the application link you just open your application and you can see the front end. Like it will ask you your personal details and your academic details and your experience and everything, it will ask you as a front end. So now when you submit your details after filling your application, so you get some notification like okay, your application is successfully uh, accepted or something like that, it will display you. So it will provide the functionality, but it doesn't give you an implementation part. So it will hide the information. So that is a concept of an abstraction in Java. And we can achieve this abstraction in Java in 2 ways. Like you can use a concept of an abstract keyword, or else we can use an interface concept. So abstract is a keyword which you are used along with a class and the method to implement the abstraction. That is one way. And we can use the concept of interfaces and you can implement this abstraction concept. That is a second way. So by using this abstract class and method, we can implement the abstraction concept 0 to 100%. We cannot say like 100% I can implement abstraction by using this abstract keyword, because your abstract class will consisting both abstract and non-abstract methods. So simply an abstract method is nothing but we have a method but it doesn't having any implementation. So at that time when you see the method, we don't know what it is going to do. So we don't know. We don't have any implementation there. So we have to hide that information there. But because of your abstract class is having both abstract and non-abstract methods, so that non-abstract methods will give you somewhat an information or somewhat an implementation of your application. So because of that reason, your abstract class and methods does not provide you the 100% abstraction in object-oriented programming. I hope you all can understand. Because if your abstract class is having both abstract and non-abstract methods, even abstract methods can hide information and non-abstract methods can show some of an information. We cannot implement abstraction by using this abstract keyword 100%. So depends on the number of abstract and non-abstract methods we have in your abstract class. So we can define how much percentage of an abstraction you can provide it for your application. So whereas the second method, by using the concept of interface, so we can implement 100% abstraction, because we know interface is similar to your class. It's having a static variables, and then we have a method which doesn't having any implementation. So when we see an interface, we know that what are the variables we have and what is the method it is going to use in your feature, but we don't know how it is going to be implemented at that time when we see an interface. Because I think you already have some experience when we discussed about the inheritance concept, where we implemented the multiple inheritance. Because I said already multiple inheritance we are not implemented in Java directly. We can implement the concept of interface. So we can implement the concept of like multiple inheritance in Java programming. So at that time we seen that like we have an interface which is having the static variables or the final variables, and then we can have a methods that doesn't have any implementation. So when we have a method it doesn't having any implementation, obviously we can provide that implementation at somewhere, but is not at the interface level. So we know that we can implement later your methods at your child classes. So this is a way how we are going to provide an abstraction in object-oriented programming. And here today we are focusing on abstract keyword to implement the abstraction. For the next classes, when we discuss about the interfaces concept in depth, there I'll show you how you're going to implement the 100% abstraction by using the interfaces concept. So simply an abstract class is nothing but a class which is preceding with a keyword abstract. So class which is declared with a abstract keyword simply is known as an abstract class in Java, and that can have both abstract and non-abstract methods. I already said, like we have an abstract method without having any body. We have a non-abstract method which is having some definition or some body of the statements we have inside. And coming to abstract method in Java, so which the method is having the keyword abstract before the method name. So such type of methods in Java programming is said to be an abstract methods. And these abstract methods that doesn't having any implementation. So when we have a method is not having any implementation, if you are not implemented in future also, the functionality we didn't get. So what simply we have to do? So we have to implement or we have to provide the definition of this function, not at that point, but we can do in future. So that's what the concept of abstraction by using an abstract keyword. So I'll show you one example. How you are going to implement this abstraction by using abstract keyword in Java. Okay, here my class is rectangle. No. Okay, my class is test1, I hope. Yes, test1. So I'll show you that program. So I just open that program. So here I'm going to open my program which is demonstrate this abstract keyword which I'm going to use along with my class name and my method name. And here you can see this is my keyword abstract I'm using before my class. So class is a keyword which is used to define a class, and here my class name is shape. And this class shape is an abstract class because I have a keyword abstract before my class name. So it's having one variable, it's of a type string, and my variable name is color here. And this is my abstract method, and my abstract method name is area, and it is of a return type double. So here I have one more abstract method. So abstract string to string method. So now here I have a constructor. So by this constructor I am going to assign a value, and here you can see why I am using this keyword here is because I know my instance variable and my local variable both are same. So you can see color and color here. So now the compiler doesn't get any confused by using this keyword. So it will take an instance of your instance variable, and it is going to assign with a value provided by your constructor. So this dot color equals to color, and here it is my non-abstract method. So now you can see here I don't have any abstract keyword before my method name, and here by using this get color I'm going to return what color I am assigned for my shape. So now this is a class circle, so which is going to extend it from my class shape. And here in the circle class, I'm going to find the radius. So now here, this is my constructor because the name of my method name is similar to my class name. And here I'm passing two arguments. So one is color and second one is radius. So I don't want to pass another color. I just want to take what color I'm assigning through my parent class. So because of that, I'm using super keyword here. So super is going to instantiate your parent constructor. So by parent constructor, I'm going to assign the color to my shape. So that I'm calling here. And then here I'm going to assign my radius by this constructor. So this is a method area. And here you can see this method is in my parent class. And now the same method I'm going to implement my child class because of this is overriding. So now override double area, and here I'm going to return pi and r square. So math is a class, so which will give you the constant value of pi, and math is a class which will provide you power, that is a square value. So because we know pi r square, right? So simply you can give 3.14 multiplied with r star r, or else you can give like this. And now I have another method which is my abstract method. I am going to override in my child class. So simply I can use this. So these are my access modifiers. I'll explain you all these key things at the time of when I am discussing access modifiers and specifiers. So here I am using my abstract method, and for this method I am going to override, right? So by returning the color and area of this particular thing. And then here I have one more class rectangle, and which is going to extend it from the same class shape. So now you can see this is a hierarchical inheritance. So now I have double length and width, and I'm using rectangle constructor. I'm going to assign color for my rectangle, and I'm taking length and breadth. And here also my instance variables and the local variables both are same. Because of that, I'm going to use this keyword here. And by using this super color, I'm going to instantiate or call my parent class constructor. So that is the purpose of super actually. It is going to call the parent class constructor. Remember, parent class constructor I'm going to instantiate by using this super keyword. So then I'm going to override the same methods in this rectangle class itself. So I'm going to find the area by multiplying length and width, and I'm going to override toString and provide the color of my rectangle by my constructor, my parent class color, and I'm going to print the area of a rectangle by this method. And here it is my main class because my main method is here. And then here I'm creating objects. Right here I'm creating an object because here my methods are override. Because of that, when you are using overriding concept, you have to create an object for your child classes with the reference of parent classes. So we already discussed hierarchical inheritance in your Java programming at the time of inheritance concept. I'll show you you have to create for each and every child class, because the hierarchical inheritance we have a multiple children for the same parent, and each and every children is having their own properties and their own behaviors along with the parent properties. Because of that reason, we have to create the objects for each and every child classes. So here I have two child classes called rectangle and circle from my parent class shape. So I need to create an object for circle and rectangle with the references of my parent class shape. So because I need to override my methods which is provided in my parent class. Because of that reason, I'm creating my objects to child classes with the reference of parent classes. And now simply I'm calling the methods s1.toString and s2.toString, which is going to call inside the area methods of the things, and it is going to display the color also, right? So this is, so simply you can do s1.toString and s2.toString, and you have to give the printf statements also there. So now I just run this program. So I can give here Java C. So Java C, and my program name here it is test1.java. And here it is Java test1. So now you can see shape constructor is called, circle constructor is called, and shape constructor is called, and rectangular constructor is called, and circle color is red. So because when you are using the concept of constructors, at the time of creating an object itself, you are passing the values. Yes or no? You are passing the values. For circle, you are providing red color, and the radius is 2.2, and for rectangle you are providing yellow color, and the length and breadth are provided as 2 and 4. So because of already how you're going to initialize the values of your data members with constructors, right? So now it will show you your rectangle color is yellow and the area is this one. So this is a concept of abstraction by implementing the keyword abstract and the concept of polymorphism in Java programming. I will share you today attendance and yesterday attendance also in live chat itself. You just go through and provide attendance for these 2 days, because I'm a little bit busy yesterday. Because of that reason I didn't provided the link. Just go through and submit your attendance for today and yesterday. So if anyone is having doubts, you just ask me in live chat, so I will clear your doubts. So just 2 minutes. So I will share the attendance links.